Hello guys, my name is Massenzio. I am the Vice President of SGC, and I will also be teaching you how to do some Unity today. We have my lovely assistant, Richard, over here. If you have any questions whatsoever, feel free to ask him. Other than that, let's get started. So if you open up Unity, you should see a launch screen like this. Is everyone there? Is anyone not there? I'm gonna, just for the rest of this thing, I'm just gonna ask if you're not there. If you're not there, or if you're almost there but not there yet, just raise your hand, okay? So everyone's in the starting screen. Cool. All right, so what we're gonna do is we're gonna create a new project. So we're gonna go up here, click. We're gonna call this Learn Jam Woot. And we're gonna, let's do 3D, and let's add, so basically what we do is we can add asset packages. Basically what these asset packages do is that they let us, it's some default assets that Unity gives us, and hello. Just some default assets Unity gives us, lets us do some really basic stuff. For this, is there any cool stuff we can do? Let's bring in, for now, let's do characters. Yeah, let's just check out characters for now and then click done.
And you can add them anytime you want with just like the right click later on.
For now, disable Unity Analytics. That's like really, really good if you actually are like making a game that you eventually want to release. But if you're just doing some test stuff, you don't need it. Location wherever the heck you want it on your computer, and from there, create project. I know this is not constantly logging quickly to see where it is. Alright, cool. Okay. So, this is almost ready. Also, the more asset packages you include, the longer it'll take for your project to build initially. So, okay, cool. So here we are. So this is the editor for Unity. We have a couple of, it's a very small screen, wow. Okay, I guess it's because it's the low resolution. So we don't have a huge space to work with here, but basically I'm gonna go over a couple things. So first things first, just so I can explain the menu to you properly, we're gonna quickly create an object. So if we go over here, there's this blank window over here. It says hierarchy. We're gonna right click, we're gonna create 3D object, and then we're gonna click cube. And then we have a cube. So we have a cube now. So now I can explain this a little easier. So over here, we have something called the hierarchy. This is where you can find all of your objects within a scene. A scene is basically just a collection of objects that are stored together. Essentially, usually a scene for Unity is something you would say like, oh, level 1, or main menu. Like, those are scenes. So, just separate parts of the game that you want to be little containers. So, as we can see here, the only thing we have in our hierarchy is the cube. So, if we click on it, we get all this cool information over here. So this information is, this whole entire box over here is called the inspector. The inspector gives you information about the object you're currently looking at. It gives you all the components, and it tells you, and then you can also like edit values to change the object. So the first thing we see here, which is every single object in Unity has this, is the transform. If you were here earlier for Adam's lesson, a transform is basically the same thing as it is in Unreal as it is in Unity, where you have a position, you have a rotation, and you have a scale. Something to note though is, we've been learning all these different, we learned Blender, we learned Unreal, and now we're learning Unity. With that, for some reason, every single one of these programs has a different axis system. So, as we saw last time, Blender used Z for up. For Unity, Y is up. and Z is out, as we can see right here. So you see how Z is pointing directly up, or no, Y is pointing directly up, that's green. Z is pointing out that way, it's blue, and then X is red. So, as we can see here, we have position. So, first things first, let's just put this in the very center of our scene. So what we're going to do is we're going to click it, we're going to hit 0, 0. We'll click this, hit 0, we'll click this, and we're going to hit 0. So now, as we can see, our cube is in the center. Something else good to know, actually no, I'm just going to go through before talking about how to move the camera around. But here we have cube, mesh filter. These are all different. You see how these are all in their own little boxes that you can collapse? Those are all components. And basically what components are is little, like basically attributes to an object that make it do certain things. So as we can see, if we uncheck the mesh renderer component, we no longer see our cube down there. You see that? So that component actually makes the object visible. It draws it onto the screen. So we're going to open all these back up. So that's basically what you need to know for the inspector. If you want to add a component, you can click add component down here, and there's a ton of stuff you can do. Like this is how you like make an object unique. From there, let's show you how to move around with the camera. So if you want to just pan left, right, hold down middle mouse, and just move it around. Really simple. If you want to look around, you hold right click, and left click just selects. So, oh yeah, next thing would probably be good to show is, let's say we're all the way out here, and we're like, oh, all the way out here. There's no way we're going to be able to find that cube. Let's say we want to find that cube though. What we can do is we can go to our hierarchy, click cube, and then press, and then while we have our mouse over the camera, we can press F. And F will bring us right to the cube. Yes, Kevin?
In the hierarchy, does that word cube refer to that instance of the cube, or the object cube parent that you use?
Good question. It refers to the exact instance. So basically, if I was to duplicate this cube, if you want to duplicate something really easily, you just select it and then you press Control D. We're definitely going to be doing that later when we want to build levels, but for now, we have another cube. It's right on top of it. It's the exact same thing, but as you can see, it's called cube parentheses 1. If we named it the same thing, it would work, I believe, but they're both different. They're not the exact same cube. Like if I was to move this one away, you can see that they're both in different positions, so there's no way they can be the exact same thing. So they can have the same name, but that doesn't necessarily mean they're the same thing. A good way to avoid this is to just, like name them different things. This way you don't get confused. So I'm gonna name that cube 2. From there, probably something we're gonna want to do is, so you see how these cubes are really dark, and that's, you can't really see the edges on them. They look ugly. So what we're gonna do is we're gonna add directional light. Basically what directional light is a sun. So we're gonna go with light. So I right-clicked in the hierarchy. I'm going to light and I'm going to directional light. And oh, there we go. Now we can have like this nice shading on the cubes in our scene. And as we can see here, we have this little sun object. And as you can see, no matter where I move it in the world, it doesn't change the lighting because it basically simulates a light that's infinitely far away and always shining light in a direction on the scene. Hello, Justin. So this actually doesn't matter where you put it in the scene. It will always do the exact same thing. So, we're just gonna, it doesn't really matter where we put it, someone's gonna throw it over here for now. So we got our 2 little cubes. So let's try making a big floor because we're gonna eventually want a little like play space to go on. So first thing I'm gonna do is I'm gonna go back to cube. So I don't confuse myself later, I'm gonna rename it to floor. And before we go on, is there anything I was talking about that people have any questions about? Yeah?
You should like change the direction of the lights
Oh, yeah, so if I go to click my directional light and I press F, that'll bring me to my directional light. If I wanna change the, oh yeah, I should probably talk about how to move objects around. So you can hold the axis, you can move it around. If you hit E, that brings you to rotating, the rotate mode. And let's say I click this axis, I rotate it, as you can see, it's, or if I move, yeah, this will probably be easier to see. If I start rotating it, you can see that the actual, it's basically putting the sun to a different direction in the sky. So if it's coming down like this, it's over here right now. If I rotate it, it's basically shining light down this way. So you can set that to wherever you want. You can have it set directly up. And ooh, this is a pretty cool thing about Unity. It has dynamic skyboxes. So as you can see, it detected the skybox that we're in, the default one, detected that we were in a, that detected that we had a directional light. And basically what that does is, if whatever way we point it, it'll actually have a sun. I don't know if this is specific. Oh yeah, it does. So you can see this, we have like a little sun texture right there. Depending on which way we rotate it, we can, we can put the sun in a different spot. And if it's under the horizon, it actually becomes night out. So that's this really nice thing that Unity has by default. So we're gonna make it like, we're gonna make it, whoops, what is this? Not that, oh, no more, so. We're gonna make it, which one is the rotation one, rotate? Probably wanna rotate and see. We're gonna make it, oh wait, no, I'm stupid, sorry. X, that's what we wanna do. We're gonna make it high noon. And so basically the light's gonna be shining directly down. Actually, no, we're not gonna do that. We're gonna just have it tilt a little bit. This way we can see a little bit of the actual like shade on the cubes. So if we go back over here, and we rotate this around, we can see like, you know, it has a different bit of light depending on, yeah, you get it. So, like I was saying before, oh yeah, does anyone have any more questions? I'm sorry, I was going off a little tangent there. Yeah, Kevin?
So with those objects in the hierarchy again, is there any way you could like manipulate, like you could parent a bunch of instances to one?
Yeah.
So like let's say I have 10 cubes, can I have one cube object that all 10 instances will be affected?
Yeah, we're gonna get to that in a bit. I just want to quickly show how to like mess with specific objects, and then we're gonna talk about how to make parent objects and children objects where you can do exactly that. But I'll get to that in like probably like 5 minutes. So we're gonna go back to our floor. If you didn't already name it floor, I would recommend doing so. Oh yeah, I didn't really mention how to actually click rotate. Oh yeah, I did. Just press G. If I want to go back to position, I press W. So, but for now, what we're gonna do is we want to make this a very flat surface. So we're gonna go to scale X. We're gonna make that like, let's make that 15. We're gonna make Y 15. Actually, no, we're gonna make Y like 0.5, and then we're gonna make Z 15 as well. So we're not. We do not want to do that. Okay, so now we got this nice big surface. We're gonna drag it down a little bit, and let's just take this cube that we made earlier and drag it up a little bit. So now we got this nice little floor space, and from here, I guess what we can do is, for now, let's just show you guys how to actually like start your game. So to do that, let's first make a character so when we enter the game, we can actually see what we move around. So we're gonna go to our standard assets. It should be a folder that you have. Characters.
Do you want to just mention what cameras
Oh yeah,
work
actually,
first?
yeah, go back up to standard assets. What do you want to do?
Do you want to mention what cameras work first before putting a character in?
Remember it has a camera on it. I'll show that. Characters, first person controller, prefabs, and then we got our FPS controller. So we're gonna drag that onto our floor. And here we have it. And then as we can see, we have this capsule, it's like half in the floor. We don't really want that. So we're gonna drag it up off the floor, and we're gonna have it floating right up here, right above the ground. Does anyone not have that yet? Okay, cool. So what we're gonna do is we're gonna hit this big old play button up here, and we're gonna enter. Oh, that is very loud, so I'm gonna do what Adam did earlier. And, go to playback device, or no, actually, I'm gonna go to audio mixer. Where's mixer? Oh, I just spoke out. Wait, where's the mixer? Oh, there we go, I'll skip it. Alright, we're gonna turn that way down. That's a bit better. Okay, so as you can see, we clicked the play button, and now we're in Unity, or in the Unity player, and we can move around, look around since we put that first-person controller in. We can see on the side actually our exact position, and when we move, we can see it move around with us. Yeah. So everyone got that working? And we not get it working? Cool. So from there, what we're gonna do is we're gonna press escape to get control of our mouse again. And we're gonna click the play button, which is gonna end it. So now that we have that in place, we can see this cool, also when we add this first person controller, we can see this cool little camera object. So basically, a camera in Unity, you need to actually have at least one camera to be able to see anything. Because if you have no cameras in the scene, there'll be nothing to show. So, for example, if I click our first-person controller, where is it? Yeah, if I open up our first-person controller, we have this object, and we have this other object that's kind of indented in. And here's what Kevin was talking about. So, this one object called FPS controller is the parent of another object called first-person character. And basically what this means is the first-person character will share, is under the first-person controller. So if, let's say for example, the first-person controller moves around, the first-person character will move around with it. So, let's say for example, we have this cube, right? This actually will be a really good example. I'm gonna duplicate it for a second, and we're gonna, drag it out a little far out, a little up, and we're gonna scale everything down to like 0.5. If we just move this around, it's not gonna move around.
How do you scale it?
Oh, when you select on the object, there's scale over here, and then you can just set it to, I set all three to 0.5.
Right.
But yeah, you see if we have this big cube and we move it around, that little box isn't moving with us. But we want our little, like, I don't know, this I guess it's like a duck or something, I don't know. Let's say we want the head to move around with the body. We're gonna drag this up into cube 2, and then we get this little drop down, and the cube is inside the cube. And now, if I select our cube 2 again, and we move it around, the little box will move around with it. This is very, very, very important this is very, very important when using Unity. This way you can make, let's say, for example, you have like your soldier, and he has a gun in his hand, and the gun is a whole entire separate object. If you'd want to put that gun object as a child of, the soldier, this way, when he moves around, the gun will stay with him, instead of just float and then look in a random direction while he's over here and shoot in that direction where he's looking, which would look all weird. But yeah, so other than that, what do you think we should go into next? I guess the next thing we should talk about is what?
What was in your lesson plan?
Oh yeah. Alright, so I guess the next thing we should talk about, we have scene view versus game view. So as you can see right here, we're in our editor, we're moving around, but let's say we want to see what it looks like when we have what our our actual game view looks like, what our camera's looking at. What we can do is we can click the game tab that's right up here, and we can see that's what our first person controller is looking at. So And then if we want to switch back, we just click the scene again. So if we click play, we can see it automatically switches to the game tab. But let's say we're in the middle of our game now, and we want to see where our first person controller is. Because I just jumped on top of our duck. I'm going to click escape, and I'm going to click scene. And now we can see that our first person controller is standing on top. And we're still playing, because you can see the play button pressed. But let's say we want to, let's say we want to see what it looks like when he's jumping in midair, but obviously we won't have enough time to click to scene view and then see him frozen midair. So something we can do is we can click the pause button. So I'm going to click it while I'm jumping. And as you can see, it automatically brought us back to our scene view. And we can see up here that I'm still floating in midair. And that basically stopped the game just for a moment. And now let's say we wanted to do something like, oh, now we just want to try something out while the game's running. What we can do is we can actually set our values here. And when we are finished with the game and we click end, those settings will go back to normal. So just to show you what I mean, let's set our walk speed to like 15. And we unpause. So I landed because we resumed the game, and now I move very, very fast. And my head bottom is going crazy right now. So, we're like, okay, that was cool, but I just like want to discard the change. The nice thing about Unity is, if you're in play mode, you can make all these changes, but once you click, like finish, and then you go back in, it'll bring all this back to normal. And you're thinking, but how do I permanently change a setting about a character? So basically, all you have to do is change the setting when you're not in play mode. So if I go to walk speed and I set it to 15 now, and now I click play, I'll actually have that. And yeah, if I restart it, you can see I still have the setting even though I ended it. Does it make sense to everyone? Does anyone have any questions about it? Any, like, I don't know, anything you find interesting about it? Okay. From there.
Want to dock the windows?
What?
You can dock the windows.
Oh yeah, that's also a cool thing. So it's nice and all having different tabs for them. But let's say I want to see both of them at the same time. What I can do is I can click and drag the game view out. I can have it just either floating in the middle of the screen, or I can have it up on the side. I'm going to put it up on the side for now. And now you can see that I can see my scene view and my game view at the same time. And if I click play, we can see what's going on live. Which this is very, very nice when you're just trying to like find out how objects are moving while the game's going on. But yeah, for now I'm just going to dock this back because we only need to worry about one thing at a time for now. And also the window is like really small and I can't make it any bigger. Yeah. So after that we have, oh yeah. So let's start talking about physics. So yeah, we're moving around and stuff, but our thing that we have here doesn't actually like have any physics. When I just run into him, or the block is just like standing there and I can't do anything about it. So let's change that. So we're gonna go to our cube 2. I'm gonna name it, I think this thing kind of looks like a Minecraft duck, so I'm gonna call it duck. So this was our object before that we were able to control with both cubes. So I'm gonna add something onto it called a rigid body. Rigid bodies are really, really important to know in Unity. They're basically the way you deal with like real-time physics. So we're gonna click, oh yeah, so to add a rigid body, we're gonna go down to add component. We're gonna click physics, not physics 2D. We would do physics 2D if we're actually working on a 2D game because Unity's 3D physics engine and 2D physics engines are completely different and they don't work with each other really. So we're gonna do just normal physics. And we're gonna click the top thing there, it says rigid body. Also, if we wanted to add rigid body, another way we can go about doing that is we can click the little search box up here and we can do rigid body, and you can see it there. So now we have this rigid body. We can see mass is 1, drag is 0, so basically it won't really slow down in midair. And yeah, there's a bunch of cool stuff you can do with it. So just to see this working, we're gonna lift this up in the air a little bit. And we're gonna click button. And you can see how it just fell down. Oh, woo! Okay, but yeah. So yeah, you can see that when it, it actually fell and stuff. But now let's say we want to actually like, you know how it just fell, but it didn't really like do anything else. It just kind of like sat there. Let's say we want to make it like bouncy or something, kind of like how when we were learning on Unreal earlier, how the balls that were coming out of the gun were bouncing around. So the way we go about doing that in Unity is I clicked all the way back to assets. You can also see it in your project folder. We want to go all the way back up to the top. And we're just gonna create on the top here something called a physics material. There we go. And we're gonna call this bouncy. Basically, we have all this cool stuff up here. So we got our bounciness variable. This goes between 0 and 1. This is basically I believe this is, if it's 1, it has 100% mechanical efficiency, which means literally it bounces and it'll rise up to the same height as it fell from. So basically it won't ever just like stop bouncing. So we don't really want that. Yeah, what's up?
Can you make it one?
Good question. I don't think you can, because we could do, later on, I think I'm gonna have enough time for it. But yeah, because we're going through this actually really quickly. We could go into how to like make that happen though. We can go into scripting and like actually show you how to like say like, oh, if it hit the ground, add a force to it that's double what it landed on. Yeah, what's up, Chris?
Can you say what you did with bouncy again?
Oh, do you have the object created?
No, okay.
Okay, so I'm gonna do that over. So basically, I'm just gonna delete this for now. So we're just all the way up in assets. If we're all the way down the folder, we can see this little hierarchy here. We're gonna go all the way back up to the top. And we're gonna right click the hierarchy, or the, our project folder. And we're gonna go to create, and we're gonna go all the way down to physics material. Do you see it? It gives us a name that we can automatically type in. I picked bouncy. Press enter. And we're gonna set our bounciness to, let's have fun with it and start. Let's do 1. And what we're gonna do is we're gonna click our duck, and we can see here, we have all our stuff here, and we can actually drag our component right into,
Collider.
Where is it? Oh yeah, the collider. So we can see we have our box. I'm gonna try this back. So we can see we have our box collider here. It takes in a physics material. So that's where we're gonna bring our physics material. So from here, we can play. He bounces, but he doesn't bounce all the way. That's interesting. Oh, that's interesting.
Click on the material. The bounciness is an average of the floor's bounciness and its bounciness.
Oh, yeah. So he had a good point. So we don't want to do average. We want to do, I guess, maximum.
Sure.
Yeah, sure. Let's do it. And that should make it work.
That'll use whichever one's higher.
Yeah. So basically, yeah, like you said, that's the one. Whichever one is hot. If we said bounce combines a maximum, that basically just sets it to whichever one's higher. So our floor actually has its own bounciness level, which I believe is 0, which actually makes sense because before it was averaging the two. So the average between 1 and 0 was 0.5. So we were getting half the height each time, but we just set maximum, and our duck is bouncier than the floor, so it just defaults to that. So as you can see, we have this duck. We hit him, he bounces away, keeps him bouncing around, rolling around. Never will stop, actually. Oh yeah, the reason he actually stopped bouncing there was because the cube that we have there is not bouncy so that's the reason we stopped that. So I can actually click on the, oh yeah, that's actually a good point to state. If you apply like a physics material or other components to the parent object, that won't necessarily apply them to the child object. So if we want to make the child object bouncy as well, we could drag that physics material in to our head, which I'm actually gonna name this head right now. It's good practice. Not here. Head. Cool. So now they're both bouncy. So if we go back to the editor, get it. Okay. Well, that was a good example, but you get my point. We made the head bouncy too, so if it actually hit the head, it would also bounce. So cool.
Oh, and the way that colliders work with parents and children is that if the parent has a rigid body and the children don't, but they have colliders, they'll act as if they're colliders for the parent's rigid body. So you can create complex collisions if you create a bunch of children with their own colliders, instead of just having boxes on every object. What's up, Sam?
What you said?
If you made one bouncy and everything else normal, would they all bounce on the floor? Or do the objects themselves have to be bouncy too? The boxes?
So they don't have to. So basically, I can make the floor bouncy, and it essentially would work like a trampoline. So yeah, let's make this trampoline. So let's take our bouncy. So let's press F to focus, and we're gonna scroll in a little bit. Let's make our let's get our bouncy thing. That's the super bouncy. Set the material to our box collider, and now let's take our. Oh yeah, this is actually a good thing to know. So now let's take the bounciness off of our duck and our head. So what I'm going to do is I'm going to select both by doing. I'm going to click this one, and then I'm going to control click this one, and now I can get the information of both, and we can see they both are bouncy. So we'll say it's bouncy here, and I'm going to click this little thing, this little circle here, and I'm going to click none. So now it doesn't have the bouncy maturity anymore. So this duck is no longer bouncy. He's just gonna, and that's it. But the floor is bouncy, and we also have our thing set to maximum. So it should actually act the same, but instead of the duck itself being bouncy, it's the floor being bouncy now. But it should act the exact same, and as you can see it is. And you know, duck bounces around, goodbye. Oh shoot. Okay. So yeah, there you go. I'm actually gonna make this a lot bigger. So I'm clicking my floor, and I want to make this a lot bigger. So I'm just gonna, I'm gonna set this to like 30. I keep the Y the same, and I'm gonna set the Z to 30. There we go. Cool.
And you can put simple math in those boxes, like 5 times 2, and it'll just do the multiplication for you. So if you have a value already in there and you want it doubled, you can just put times 2.
Good point. So yeah, so for example, I want to set this to 60. I can do 30 times 2, and that sets to 60. If I don't want that right now, it's going to undo. Undo is the same as most other programs. It's Control C, and or redo is Control Y. I've rotated the duck a little bit, so if we click play, like he'll just start like rotating on his own, flying away. But yeah, so so we can actually like go into our stretch. Wow, we're doing this really quick. So yeah, we actually got through this pretty quick. So
touch scripting.
oh yeah, that's true. We haven't touched scripting. So basically, this is the general overview of how to use the editor itself. So we're gonna go into scripting now, and scripting is the real meat of Unity, where this is where you can do most of your stuff. So, for example, our first-person controller, he has an object we brought in, but it has its own scripts on it. And if I double-click this, it's gonna open up Visual Studio. But but yeah, I should probably explain what I just did. So I clicked my first person controller. I scrolled down to the thing called first person controller, and this is script. This is cut off. And I double click the script here. And it opened up Visual Studio, and we can see a whole bunch of code here. This looks really confusing. It's because these people, you know, they knew what they were doing when they were making this, and this is very complicated. We can make a much simpler system, but we already have this, so we're going to make something different. Is there anything anyone wants to specifically add to this scene to make it a little more interesting?
Can you just go back real quick, show me where the script was, I missed it.
Oh, sure. So we're going to go to Unity. So basically we have, go to our hierarchy. We click FPS controller. You have that, right?
Yeah.
And now we clicked it. So now we go over to our inspector. We scroll down to first person controller script. Do you see this?
Yes.
And you see the word script and then this little box here?
Yeah.
Double click it.
Okay.
Did it open up Visual Studio?
Yeah.
Okay, cool.
Thank you.
And yeah, so there's a ton of code here. This is really complicated. Don't worry about this. I'm just gonna X out this so we don't have to worry about it. But yeah, that's basically what's running under here to actually make the first person controller, you know, move left and right, have the head bob, look around, and all that type of stuff. So what's something to do? Oh, cool. You know what we can do? We can add a script to our duck to change color when it hits the ground.
Sure.
Does that sound good? So what we're going to do is we're going to click our duck. We're going to scroll all the way down to the bottom. Click Add Component. We're going to scroll down to Scripts, or actually no, not Scripts, sorry. We're going to click New Script. And it's going to give us a name. We're going to call this in case we want to add anything else to this later and we want this to generally control everything in our duck, we're going to call this duck controller. And we're going to keep the language on C#. If it's set to JavaScript, just set it as C#. We're going to be learning C# right now. Click Create an Add. That'll create a duck controller script to our component, to our object. Yo, what's up, Chris?
Did you choose C or Java?
C. C#. Yeah, and it should be down here. And then we also get it on the top of our project hierarchy. So just to keep everything organized, we're going to right click this, we're going to click Create Folder, and we're going to name it Scripts. A little floral. And we're going to drag our duck controller into the scripts. This is just to keep everything organized. If you start keeping everything on top, you're gonna get like a mix of models, prefabs. Oh shoot, should have talked about prefabs. Okay, so this is very, very important, and I should have talked about this earlier, but there's this very important thing in Unity called prefabs. And basically what a prefab is a copy of an object. So let's say we want to, let's say in a random game, it's like the super dark dungeon, you know, like one of those jump scare games, and we want to have a couple of lamps that are around the whole entire scene that give very low light. It would kind of be a pain in the neck to, you know, have it, let's say we have even multiple levels of it. So we have our light, and we don't want to just copy and paste it and then have like oh yeah, let's say like we copy and paste the lamp and we put it all around our scene, and then we're like, you know what I should have done? Should have made the lamp a little bit dimmer because this whole entire room is super light now. You'd be like, okay, now I have to go through every single lamp and change the brightness of it. That's a huge pain in the neck. Wouldn't it be nice to just be able to go to one of them, change the light on it, and then it'll change it for all of them? If so, then yeah, prefab is what you want to do. So it's actually really simple to make a prefab. So basically all I'm going to do is I'm going to create a new folder called prefabs just to once again keep everything organized. Prefabs. Spelled it wrong again. we're gonna open up a prefabs folder, and we're gonna take our duck, and we're gonna drag him in, and bam, we just made a prefab. Easy as that. So from here, we have our duck, and let's drag a couple more ducks into the scene. So we're gonna take our duck, we're gonna drag him into the scene. Let's drag like 3 ducks in, and let's move them around a little bit. So I'm gonna click on a duck, I'm gonna drag him out on the X-axis, a little on the Y or Z. Take another one, drag him up, away, and I think there's another one here. Is there? Yep, one more. And we're gonna drag him out here. So we got our little army of ducks here, and now what we're gonna do is, let's just click play. They all do this stuff, you know, they're bouncing around, having a good time. But let's say we want to change the setting on them. What we're gonna do is we're gonna click our duck that's in our hierarchy, which we can find in assets, prefabs. Is that anyone lagging behind at all? Everyone good? Cool. Oh, yep.
How did you turn it into a prefab?
Oh, okay. So I took the duck and I dragged it into our project folder. Do you get how to do that?
Yeah.
Okay. And then from there, I dragged it from the project folder into the scene, or into the hierarchy. Also, you can drag it directly into the scene if you want to. And then I'm just gonna pull it up a little. Either one works, personal preference. Do I have my water still? Whatever. So from here, let's drag the directional line down. And this doesn't really matter. I just want to have everything on top of each other. So let's make let's say we want to change let's say we want to make our duck shorter. What we can do is we can click the duck in the project folder, and then we go over to our scale, and it's gonna hold. This is actually a good way you can just like finally change the scale or rotation or position of something. Is you just click and drag the actual letter. So I'm gonna change the Y by clicking and dragging the Y, and drag that left, which makes it smaller. And I can make like a really flat duck, or I can make it like really tall, and it changes all of them. Which this makes our lives a lot easier when we want to change like many things in the scene that are essentially the same thing. So let's make them like, you know, like, yeah, that's good. So now we got our army of ducks, and now they're short. So we can play, bounce around, turn the super speed, and there we go. So that's basically how prefabs work. And yeah. So from here, our duck is kind of boring. So I guess what we can do is from here we can change the color of them by using scripting. So what we're going to do is, whatever, yeah, let's reload. Or not, okay, whatever. So we're going to click our duck in our, we're going to click our duck prefab. We're going to scroll on down, all the way down to the duck controller script. We're going to double click it, and it should open up this. Tell me, give me a thumbs up when you're there. Is anyone having trouble getting there? Okay, so we have okay. So here's the general. Okay, so C# scripting is a lot like how C# operates. If you have ever coded in it before, if you haven't, it's not really a problem. It's pretty easy to learn. So we have these two functions here. One's called start and one's called update. You'll always, when you make a new script, you're going to get these two. And what start does is on the first frame that the object exists in the world, it will run this code. So this is usually good when you want to, make sure all the default values of a certain object are what they are. So once again, go back to the first person shooter example and say, let's say this is our this is our, I don't know, let's say this is to like control firing a gun. We want to make sure when you spawn in, you have full ammo. Yeah, for example, full ammo. So we would set something like, for example, a int named ammo would have like 30 rounds in it, or yeah, you know what I mean, something like that. For now, we're not making a gun, so we don't have to worry about that right now. But update is the more important one. Yeah, the more important one. Basically what it lets you do is every single frame. So, if you guys don't know what frames are in a game, it's basically every single time the screen draws like a new, basically every single time a draw goes to the screen. So, in a game that looks really smooth, it's 60 frames per second. So like, basically 60 images show up on the frames, on the window a second. So, and if that was the case, if it was running 30 or 60 frames per second, update would be called 60 times for every frame. So, yeah, that's that. So, let's try doing something simple first. So, let's say we want to have, what's this one?
You could just move it sideways.
Oh yeah, sure. Yeah, so that's something we can do. We can move it sideways first. So to do that, what we're going to do is we're going to access something called, well, you guys already know what it's called, transform. So if we want to move a object sideways, we're gonna move the transform, let's say x-axis, for example, to the right. Let's say that's what we want to do. So what we're going to do is we're going to call transform, no caps, transform, which also Visual Studio makes your life a lot easier. So let's say you want to like find transform, you keep on typing it out. Oh, transform's right there. I just click enter, it fills it out for me. We're going to say our transform dot position dot x. So our x value plus equals, which means, so we're going to take our x position and we're going to add a certain value to it. So let's say we do 2.
You can't set it. Transform, do transform.translate.
Oh yeah, okay. So if you want to get the x position, you do transform.position.x. If we want to change the position, however, we do transform.trans. Oh.
I thought it was translate.
Did it change it? I don't think it's transform. Yeah. It's not
No,
that.
it's transform.translate. It was right there.
Sure it's, oh, I probably do transfer dot position dot, I guess set. I feel like there was an easier way to do this before.
It's transform.translate. I saw it in the list.
Sure you saw it?
I'm sure I saw it.
Okay, there it is. Cool. And once we open up so basically I did transform.translate, and once we open up the parentheses, we should see something called vector3 translation. So what we want to do is actually we don't need to worry about all this stuff on the end anymore. We're going to want to make a new vector3, and then we're going to want to add, some x. Yeah, so what we're going to do is we're going to make a new vector3, and we're going to do actually before we do that, something nice to have is at the start of our frame, if you just wanna, if you know you're gonna be messing with the position a lot, it's good to call, what is it? It's good to say like my position, or I'm gonna call it my pos. And it's gonna equal transform dot position. So if I know I'm gonna be using this a lot, this is a good thing to do. And we have to set this to a vector 3. So basically, we have a vector 3, which is an x, y, z. So that's 3 floats. Float is just basically a decimal point number, you know, like 5.5 or something like that, called my position, and it's equal to our current position, which is our transformed position. So now we're going to translate. We're going to make a new vector 3 called, or we're going to do my position dot x plus 2 my position dot y and my position dot z. And that's basically all. Maybe we need to close out 2 parentheses.
Translate moves it that amount.
Oh,
Sets
it
to
does?
that position. Yeah.
Okay, cool. So then we can, so sorry about that. I haven't actually, because usually you don't have to use translate, especially if you're working with physics. So I actually haven't used this in a while. It just moves it the specific amount. So all we really need to do is actually change it to 200, which means we're moving the our current object forward 2 in the x position, not moving at all in the other 2 axes. So, I'm sorry, I'm like losing my voice already on this. So, basically, let's just test this out to make sure this works. So, we added this script onto it, and I believe it compiled, yeah, compiled. And usually when you just go back to Unity, it automatically tries to compile your code. If you're not a CS major and you're a freshman, basically compiling code is just, once you've written code, you usually do something called compiling, which turns into something that the computer can recognize, and that's really it. But yeah, and then if there's a problem with what you wrote, it'll tell you that you did something wrong. And let's just say, for example, let's just say we did something stupid, and obviously that's going to give us an error. But we save it, and we go back to Unity. We have this little, there's something wrong down here. I double click it, it'll bring me right to where it is. Also, if I go back to the editor, it will tell me, like what's actually the problem, which I put complete gibberish, so I didn't actually know what to do with it, so it just told me something else that wasn't the case. So I'm just gonna erase this. Now it will compile, and once we save, we just get a couple of warnings. We don't have to worry about those right now. Also, it brought us to the console tab. The console tab will be is really useful. Let's say you're having trouble, you're not really sure like what your script is doing. For example, we want to find out the exact position every frame of a certain object. What we can do is we can actually during while running the game, we can actually have stuff send out to the console and tell us what's wrong, which I'll get into in a second. But for now, let's just try playing the game and see what happens. Whoa! Definitely went fast. Now you're thinking, that went like really far, but you only set it to 2. Why is that? Shouldn't that just been like, just 2 units forward? But the thing is, you have to realize is that's 2 whole units every single frame, and we have a really high frame rate right now. It's probably over 100, which means because we have such a high frame rate, it's going really fast to the right. So you're like, how do I actually fix that? A really easy way to fix that is using a function called time.delta time. And so what we're going to do is we're going to change our 2 here, because what we want to do is 2 units per second. We're going to erase that, and we're going to do time dot delta time times 2. And basically what time that delta time is the amount of time in between each frame. Yeah, what's up?
I believe you can also multiply the factor of 3 by as well.
Oh, yeah, I can do that as well. That's actually a smarter practice to do, because if I had to do time that delta time on each one of these, that would just take up a lot of code. So I'm actually gonna use that. So I'm actually gonna erase that for now, and at the very end here, right after the vector 3, I'm gonna do times time dot delta time. And basically what this does is, it actually multiplies each float in the vector 3 by time dot delta time. So if I set this to 4, for example, it would also move it up by 4 per second now. But basically, like I was saying before, what time dot delta time does is, every single frame, it will, the time dot delta time will say the amount of time in between each frame. So basically what that means is, let's say I have time dot delta time times 2. Let's say between frame 1 and frame 2, it's like, if it was a quarter second, it would be like really low frame rate, but let's just say it was. A quarter second. A quarter second times 2 is a half. And let's say it keeps on doing that, basically after a full second, it will add up to 2 if you do times delta. Time dot delta time times 2. It's kind of confusing, but once you work with it more, it'll make sense. Yo, what's up, Josh?
I don't know C# too well.
Yes.
But wouldn't it be better to define that like change in speed vector once, just kind of like vector speed instead of allocating it every single update call?
Yeah, it would.
Okay.
But yeah, I'm just setting it like this right now. I could do it like that. That would be smarter to do. I just want to do it like this right now, just to show a line of code working. We can make it.
Teaching bad code.
Yeah, I know. He was my systems TA, so yeah. But yeah, yeah, we can fix up the code in a bit. But right now, I just wanted to create this to show you guys like how it works essentially. Because if I start putting the like vector 3 all the way up there, it's just nicer to see all in one line for now. When you're making much huger projects, this is a really bad thing to do, just like saying this and then having some values in the middle of your code like that. You usually don't want to have any like what we call like magical values or magic numbers in your just like willy-nilly defined in your code like that. But yeah, if we run this now, we should see them move a lot slower. They are moving, they're actually not moving in global space, so they're all sliding in different directions, but they're all moving to the right of themselves. So as you can see, this guy's on his side, so he's actually moving right like into the ground, and that's why he's bouncing up and down like that. While, you know, let's say if I kick him around, yeah, you see he'll start sliding to the right of himself. But yeah, that's that. So that's how we basically can get the get like, you know, an object to move right. Let's clean this up now. So like I said before, it's bad to do this type of stuff. So what we're gonna do is we're gonna cut this whole entire new vector 3 out, and we're gonna go all the way up here, and we're gonna make this new variable called speed. So we're gonna call vector 3 speed, and or actually let's be a little more verbose. Let's call this. Let's just call this. I don't know, right speed. This is just for testing anyway. So equals our vector 3 that we just made before, and now we can just go down here and say right speed. And also, as we can see, Visual Studio is actually really nice. It knows that we define something like that, and I started typing out right speed, and it's like, oh yeah, you already have a variable like that. You can just press enter, and it'll fill it out for you.
You also shouldn't use the transform property, because that doesn't get component under the hood.
Yeah, I don't even need to actually use this right now, so I'm just gonna get rid of this altogether. So this is actually all we really need right now. So if we ran this again, we can see it would run the exact same. Okay, go around stuff. Yeah. What's something else we want to do? Anyone have any? I don't know. Does anyone have like any specific thing they want me to explain? Because we actually have a lot of time.
You said earlier you were going to make the ducks change colors when they hit the ground.
Oh yeah, that's a good point. So
I think that'd be fun.
I guess I'd use the collision enter for that.
Yeah.
So
You can right click and open up a menu to add any of the mono behavior things you want.
really.
Yeah. It's super cool.
I
You have
can
to
just-
right
I
click
can just-
inside the class, yeah, and then implement mono behavior
Oh cool. Wait.
down the bottom.
Oh shoot, that's sick. I didn't even know that. Okay, so Richard actually brought up a really cool thing. So basically, I said before there was start and update, and those were for the most part the main two things you have to worry about. But there's also a lot of other things that can be called that are also going to help you. So for example, something I'm going to do right now is called on collision enter, and we can see it right here actually. So we're going to check that out, and then we're going to click OK. And for those who are having trouble finding that, you can literally just copy. You can literally just type this into Visual Studio under update after the closing parentheses.
How did you get that dialog box?
How do I get the dialog box? The big one I had up before?
Yes.
Was it I right clicked and I went all the way down to implement mono behaviors. And from there I just scrolled down to on collision enter, which I already added so it's not here. I checked it and then I clicked OK. And then it should automatically create this. I did not know that. Thank you, Richard.
I learned that recently, it's very useful.
Yeah. So basically every single time our duck enters another collider, which basically means, so right now, let's say my hand doesn't exist. This thing is just floating in the air. It's not really in anything. It currently is not colliding with anything. When it's on the table, it's colliding with something right now. So basically, if this is floating in the air, this function would not be called. But if it's on the table, this function would be called once. And as long as it stays on the table, it won't be called again, because there's another function called on collision stay, where anytime that it's been on the table longer than 1 frame or 1 cycle or however it handles it, it will be called. But for now, we're just worrying about the first time it hits the table, because if we did the other way, it would kind of just rapidly change colors. It would be like, oh, I'm colliding, you're colliding, it would like go crazy. So right now, what we're gonna do is, so we have on collision enter. So basically, as long as the duck collides with anything, so whether it's another duck or the floor or anything, we don't really care right now. As long as it collides with anything, this is gonna be called. So now what we're gonna do is we're gonna do what is it again? I guess mesh render.
Yeah. They got rid of all the ones you have to do get component.
Wait, I can just call mesh render now, right?
No, you have to do.
I saw things get
mesh
component for
render.
it?
Yeah. They pulled out all of the properties because they're inefficient and people use them too much.
Yeah. So we have this thing called get component. Now it looks kind of, it's like, oh, why do I have to do this? So basically, like I said before, when we're looking at our inspector, remember how I said all these are components? So basically, what we're doing over here is we're getting this specific component. So right now, I want to change just the flat color of one of these objects, and I know that the thing that draws it, and I personally know that the way you can change color is through mesh render. I basically wanted to get the mesh renderer, so I typed in get component, and then you have the little angle brackets, and I typed in mesh renderer, or should highlight it blue if you spelled it right. And because it's a function, you have to do a open close after it. Open close parenthesis after it. So from there, we're gonna do dot. I think we can just do color.
Material.
Yeah. So we can do dot material, dot color equals new color, and let's just do color dot, oh wait, I don't even need to do new color, I can just do color dot whatever. So we're actually gonna erase that. We're gonna do color dot let's just do, what do you guys want to do? What color do I see here? First color here.
Cyan.
Cyan, alright. So for now, let's just make sure this works. So does everyone have this written down? Okay. Does anyone not have it written down? Okay, sounds good then. So as you can see, we don't have any errors, so we're good to run. Now, when it's all land, we can see that the body of it, which is the thing the script is attached to, is now cyan, which is awesome. But what we want to do is we wanted to change our random color. So the way we're going to do that is, and also this way, you know, it has a different color every time. What we're going to do is we're going to make a new color, and what we can see is, oh, there's 3 options that we can do. So we can see, oh, float R, float G, W. So that's probably RGB. So a cool thing that we can do is we can just get 3 random numbers for the red, green, and blue, and that'll probably make a random color. So let's do, maybe we can do random dot range, I guess. And then I believe it's between 0 and 1 for floats. Yeah, that makes sense. Is it between 0 and 1 or is it, yeah, that's what I thought. And we're basically going to do that for all 3. So I'm going to copy that. There we go. So we have our new color, and within our color, we have random red value, random green value, and random blue value. So if this works, this should create a different unique color every single time it bounces for every single duck separately. So I'm going to save it, I'm going to click back to our Unity editor, and we're going to click play. If we bounce, we can see that, I guess it wasn't, I guess it is 255. So it didn't work because I guess, let's just make sure this works.
Oh, they're not floats. The range function takes floater integers.
Oh, I'm stupid, yeah. Oh, wait.
So it was giving 0 for every single one, every single time. Just tack an F at the end of one.
So, okay, so fun fact about C#, you need to, what is it, when you want to specifically define something as a float, you want to put an F at the end. So, before I had it between 0 and 1, so it was either going to be completely black or completely white, which is the reason we didn't see anything. And I also think that for min and max, it doesn't include the upper bound. So it was just, all of them were just black. So now this should fix it, because now it's just any flow between. So now we're gonna get the 0.5s, we're gonna get the 0.99 maybe, you know, all that stuff. So let's see if this works. Yeah, there we go. All bouncing around. You see how it was just sitting on the, see how this duck is just like laying here and he's not changing color? It's because he's staying here. He's not entering a new collider. Because basically, it's, I'm not being, so for on collision enter, it's not being called once, sitting there, not being called again, lift it up, once I place it again, it'll be called again. Yeah, so that's how we do that. Also, this might seem like, there's all this incredibly specific stuff I need to know how to, like, just give it a random color. don't be too worried about that. When you're actually like doing this on your own, it's not as hard, because what you do is, let's say I didn't know how to do that. Literally, I go, Unity, how to change color of object. And for 99% of the time, a page that'll come up is answers.unity3d.com. Basically, Unity has this a website called answers.unity.com, where they have just tons of people like you, just not really knowing what to do with Unity yet, just are asking questions like crazy, and tons of people are just replying to them and, you know, voting on them. So you see this person has 22 votes, which means they're probably right, and also, and also is marked as best answer. So you're pretty confident that like this is the correct way to do something. And whenever you're just like not sure how to do something, just Google it. 99% of the time you'll get answers.unity3d.com, and that's how you'll get, like, if you guys are entering into the game jam, let's say in a week or two, and you decide to use Unity, like, this will be your ultimate resource. My first game jam I did, I was just trying to make a simple, like, 2D ball game in Unity, and I was like, okay, so I made a circle, I made a couple of like boxes to keep the ball in place. Now, how do I change like gravity on the ball? And then I like Googled how to change gravity, and then got a Unity answers page. And then from there, I just kept on Googling, and through doing that, you end up learning actually like how to use like these specific components, and you do end up learning how to use Unity better and better every single time. So don't be afraid of like not knowing how to do something and like having to Google it. That's a really, really normal thing to do for Unity. But yeah, so like you can see that, oh, this is like essentially what we originally did before. Remember? Yeah, he did it a little bit different here, which I guess you could do it like this too.
Maybe.
You could. I've done it in like the last version.
Okay.
It's specific for renderers.
Okay.
But yeah, and then yeah, also the color RGB, like this is exactly what we did. So once again, if there's anything that you're like stuck on your own time that you're like, oh, I wish I knew how to do this, just Google it or just directly search on Unity Answers. Okay, so let's see what else we have. I think we actually gotta start doing some cool stuff.
You have 25 minutes.
Yeah.
I have a question.
Yeah, what's up?
For your ducks, if you go through their individual scripts, you change like a value, like change like the translate to like 3, would it just change that duck or all ducks?
Oh, you mean if you went to the script for a specific one?
Yeah.
Okay, so whether or not they're prefabs doesn't really make a difference. If I was to take, so basically all the ducks under this under this prefab, even if you change a specific one, will have the will all be running off the same script. If you wanted to make one with a different value, you could do that. So for example, what do you say one specifically do? You want to make it move at a different speed?
Yeah, like yeah.
Okay, this is actually a really good thing then. So remember how we made this thing up here called write speed? What we're gonna do is we're gonna get rid of this part, and we're just gonna call it write speed.
This is a script for.
Yeah, this was our script that we were working with before, and this is actually really important. I'm really glad you mentioned this. Whew. All right, so sorry I've been talking for now. So we're gonna make this public. And what this does is, now, if we go back to our editor, we can now see, oh, bam, after compiled, we have this cool thing called write speed. And we can set whatever value we want to it. And that's the nice part. So if you make a global variable, which means it's not in any of these functions, it's just in the class, but not in, in there, and you call it public, you will be able to see it in your inspector, and you'll be able to change the value there. And now, what you can do is, so if you know, if we just run this, we'll see nothing has really changed. They still like move to the right from their position. But let's say, oh yeah, this is also a cool thing about prefabs. So for my horror game example before, you had all those candles in the room and we turned them all down. Well, let's say we wanted one candle to be like really bright. Let's say it was a one like the player was holding, right? We could, and we want to make that one specifically brighter, we can click that specific one and make it brighter, and it won't affect the rest. So let's say we want to go to duck 2, but we want to make them a slight bit taller than all the rest. We're going to go to our transform for duck 2, and we're going to increase the scale of him. We're going to make him a really tall duck. So now he's like twice as tall as all the rest. So, and as you can see, like he's changed, but no one else has, even though they're all under the same prefab. And you know, we changed, and he still does all the same stuff. Like keep him around and you know, change his color and all that. So, yeah, so you can do that. Also, what you can do is, I click project, I'm going back up to assets, going to prefabs, and let's say I want to make them a little taller again. Notice how that one I changed didn't change. That's good. So basically, if you change one, it won't affect it when you change all the rest. When I click the actual prefab in my project window. So let's say I just want to make, I'm going to keep them short for now. Let's say, now this one is on its own. It's not following the rules of all the others, at least for scale. This is annoying. How do I revert it back? So basically, once you change a prefab like this, you have revert, apply, and select. Basically, you can click revert, and it'll bring it back to the default value, and then it'll follow the rules of the old ones again. You can actually make a negative and make them upside down. That's cool. But yeah, so that's it for prefabs.
And you can tell what aspects of it are going to follow the prefab and what aren't, because the ones that don't follow get bolded. So anything you manually change goes bold, and then it won't follow.
For some reason, all these are bold though.
Because you move them around.
Oh yeah, that's a good point. So like he just said, I'm sorry, that's different for me. Position and rotation are not the same as right here, and that's because they're in different places. So basically, if I was to revert this one, that's interesting actually. Can't revert it.
It probably doesn't do it just because it's a pain in the ass to sync the position to the prefab.
Yeah, okay, so yeah, long story short, don't worry about that. Just know that position and rotation, the reason they're bold is because they're not in the exact position that the prefab states they are, okay? Does that make sense? Does anyone have any questions about prefabs? Any more questions? No? Okay, okay, let's try some. Let's see what else we have. Alright, cool. So, that's another thing we do. We can try spawning, because usually in most games that you make, there's some sort of spawning mechanism you need to do. So, let's make it so, for example, if you left click, it will spawn a duck directly in front of you. So let's build off the knowledge we already done. So to do that, we're going to first have to somehow reference or actually let's not have it specifically spawn a duck, just so I can have a better example. Let's make a new prefab. So we're going to right click here, we're going to create, actually I'll just create it so we can see it. So we're going to create 3D object, and we're going to make a sphere. And we're just going to call this ball. So we have this ball here, just all shiny and stuff. Yeah, we can pretty much leave it as it is. Let's just drag it, we don't even need to drag it in as a, yeah, let's drag it as a prefab. So we have the ball here, we can safely delete here now that it's in our project folder, in our prefabs folder specifically, make sure it's there. And now we have something that we can reference. So, but we need to be able to reference this in code because we're gonna need to spawn it here, right? So now what we're gonna do is we're gonna make another public game object called, let's just call it spawn object. We're gonna save, go back to the editor. We're gonna click on our duck, and now we scroll down. Oh, we have spawn object, and it says none. So now what we can do is we can take our ball and we can drag it over here. So now, when we're referencing spawn object in our code, it's going to directly be talking about that ball. Does that make sense to everyone? Cool. So I guess this is the best place to do this would be an update. So we're gonna say spawn object. That's just commenting code. So let's see how we do this. So I guess we can do so we're gonna have to find out if we do a left click. So if input. So input basically handles any input that we send in. We're gonna say get mouse button, which this basically gets the press, I believe, or
That's whether it is pressed up and down.
Yeah.
There's up and down.
Yeah. So we're gonna actually want to probably get mouse button down. This way, because if we just do get mouse button, once we click and hold, it's just gonna spawn them for every frame that we're holding that mouse button down, which is what we actually. It's something we might want in the future. We can just play with it later, but for now we're just gonna do mouse button down. So when you click it down, the initial press, it'll say, okay, if we get that mouse button down, and then we get a button. I believe left click is 0, right click is 1, and then you have like, if you have one of those like cool mice that have like 2 side buttons on either side, those are usually like 2, 3, 4, 5. So if we get our left click button down, what we're going to do is we're going to make a new object, and to do that we call something called instantiate. Instantiate, and we're going to do, I believe we can just do spawn object. Oh yeah, and then we also probably want to say a specific position. Vector 3 position. I guess we have to give it a rotation, whatever. We're going to set it to 0. So, yeah, so to give it a specific position, we're going to want to make, we're going to set the position, and we're going to give it a rotation, which is used as a quaternion. Don't worry about that. It's kind of janky. But yeah, like I'm showing right now, there's a bunch of different ways you can like instantiate an object. Like you can either just include the object, you can do the object and also give it a parent. You can give it a parent in world position states, whatever that is. There's a lot of different options, but I'm just scrolling through them, and I just want to spawn in a specific place in the world. And as you can see here, I guess result 4 of 6 is position and rotation. So that works for me. This is what I'm gonna pay attention to. So we're gonna do our position plus +2 something. Yeah, just like +2 forward. So we can do transform dot position dot is there a way to just add to the x value without having to make multiple one?
You could do plus vector 3
Oh, yeah.
forward times a value.
I guess so.
Forward is a z, right? Is the x.
Oh yeah, I could just do that. Yeah, you're right. Okay, so actually I can do position plus vector 3 dot forward, which basically is 0 to the x, 0 to the y, but forward 1 in the z. And that's actually pretty nice, because you're gonna just like usually need to just like say like, oh, I just want to like have a vector that points directly in a direction. The vector 3 object has some of those already defined, so you can do forward, down, up, left, right, back. I think it's back. Yeah, back. But for now, we just want to do forward. We're just gonna put it 1 unit forward. Let's put it like 2 units forward. So we're gonna do times 2. So there we go. Doesn't like this. Vector 3 to vector transform. That is.
Oh, you need to also put the quaternion at the end.
Oh yeah, we haven't done that yet. That's fine. Okay. And then quaternion dot 0, or is there just a
Maybe identity.
yeah. Sure, why not? Let's go for it. Let's see what happens. Files, and this should work now. So looking around, bam, we actually got a bunch of them. Oh, you know why? Okay, so this is actually interesting. I forgot about this. So we on left click, this actually did work, not the specific way we wanted, but it worked exactly how we said. So because we have this set to our duck object, what it's doing is, I'm gonna pause this right now. What it's doing is it's taking this, it's instantiating it at transform.position, but transform.position is our duck's location. And because we had a bunch of ducks there, they're all spawning this ball directly in front of them, not directly in front of us, which I guess that's cool. But let's say we want to do that for us. This snippet of code would probably not be a good idea to put on the ducks, obviously, because it doesn't really have anything to do with the ducks. Like, we're just spawning an object in front of us. So what we can do is we're gonna make a new script, and probably the best place to put this would be our. But yeah, also you can see we have all these balls in here because I paused it. I'm just gonna end it right now. What we can do is we can go to our FPS controller, and this is probably a good place to put it because this is our character. So let's not put it in here for now. Let's just make a new script. So we're gonna add component, new script, and we're gonna call this let's just call this spawn input control for now. Why not? We'll press for time because we're like done in 7 minutes. So but yeah. So I created it, right? And I double clicked on input control, which opened up a new tab up here. So you should still be able to see duck controller, and you can go in between the two. But for now, we want to go back to duck controller, take this whole entire code here, cut, go here, and paste it in this update. And then I'm just going to clean up the code over here. Go. Save both of them. And then once we go back. Oh, yeah, done. So also we're gonna need to copy in Duck Controller the object we created called spawn object. So we're gonna cut that. We're gonna pop it up into input controller all the way on the top here. And yeah, there we go. And now this should work. So, oh, yeah. This is probably the most common error you're gonna get when using Unity by far. And it's called unassigned reference. It's called null reference exception. Interesting. Either way, basically what this is if we go back to our FPS controller, we can see that we forgot to set our object to an actual object. So if we go back to our prefabs, we see our ball here. So we click FPS controller, scroll down, and we can drag it in. Or actually something else we can do is we can click this little circle, and we get a list of everything. And we can just quickly search through. I see ball there, but I'm just going to search for it. We can click ball, and then we can see, oh, there's ball here. And that's the exact ball object we want, so we're going to double click it, and now it's there. And now when we play, yep, there we go, ball right in front of us. And notice how it's not in the direction we look, because our camera, because remember, if we pause it, we can see that our, that's interesting actually. So our basically our component itself, or our object itself isn't actually rotating, but our camera is. So that's the reason it's spawning this way, like, this way in front of us. It's kind of hard to say, but like, that's basically the reason why. And yeah, I guess that's just the simplest way to get started in Unity. Does anyone have any questions about this? Did I go too fast? Anything else? Okay. Yeah, we got 5 more minutes. So it's not really enough to do anything super specific. Does anyone have any specific questions about Unity? Doesn't necessarily have to be doing a specific feature. Just like really anything at all for Unity. No one has any questions about Unity? Okay. Yep.
What are some like big commercial games that have been made in Unity?
Oh,
Hearthstone.
yeah. Hearthstone. There's a good site called madewithunity.com, I believe.
Does Unity not like hosted? They used to have like their own page that had all of the games in it.
Yeah, I think it's still owned by them. I think it just you can go there.
They just moved it up to me.
But yeah, if there's a popular game that's come out, it's pretty much either been made in Unreal or
Ori the Blind Forest.
yeah, like most most studios these days are using Unity or Unreal. Yeah, was it Cuphead? That's a new game coming out. That was made in Unity. Firewatch, Superhot. Superhot's like, it's very much a Unity game, as in like it really like I don't know. It's kind of hard to explain unless you like use like a couple of engines before, but it definitely has that like Unity type of look to it. Yeah, there's just like a ton of stuff. Monument Valley, if you have it on mobile. Gang Beasts, Hearthstone, a ton of stuff. What is it? There's a recent game called Inside. It was by the creators of Limbo. That was created with it. Yeah, like a ton of stuff. A ton of like really good stuff has been made in the engine. It's one of the most widely used engines right now.
Probably is the next one.
Yeah. But yeah, so like, if you're worried that like Unity isn't powerful enough to like do something you want to do, believe me, it is. You can do an absolute ton of it. I haven't even like scratched the surface on what you can do in Unity. Also, there's a ton of, oh yeah, I forgot to even talk about the asset store. So like, there's also this tab up here called Asset Store. Basically they have, Unity comes with this huge marketplace of assets that people make, and they can throw it up on here and sell it either for free or, you know, for money. And it's just anything you can imagine, from, like a free screen shake tool that you can add screen shake to your game. So like, you know, like if, you know, like a lot of games use screen shake, so like shoot a gun, moves the screen a little bit, to whole entire like procedural world building tools that cost like over $100. Like there's the pretty much like, if there's anything that you really like want to just like quickly get started with Unity without like, you know, reinventing the wheel and building yourself, you can find on the store. There's also a ton of really, really good free assets that, if you're part of the SGDC Facebook group, I actually posted a link about it yesterday. There's like a huge list that someone compiled for a bunch of good resources that include the screen shaking I was talking about, and also a bunch of other stuff like free rock assets, like a bunch of models of rocks, sound files, you know, just like random image effects, all that type of stuff. But yeah, we have 1 more minute. Does anyone have any other questions? All right then, thank you so much for listening.